Hello, my name is Cassidy White,
And my name is Andrew Whitome.
and today we will be looking at attendance forecasts and projections for Redwood National Park based on data from 1979 to 2022 for Jamie Lancaster's BA322 spring course. Let's get started.
So Redwood National Park is a popular destination for a wide range of visitors from all over the world. The park itself attracts a diverse mix of people such as nature enthusiasts, families, tourists, researchers and scientists, and artists and photographers. The park itself is located in a very remote and rural part of the California coast that is not always easily accessible to out-of-town visitors. In order to understand the variability of monthly park attendance and get a better understanding of visitor totals in this context, we're going to review some time series data collected from the National Parks Department and create projections for what kind of attendance Redwood National Park can expect going into 2023.
Seasonality is a characteristic of time series data that describes regular and predictable changes that recur every period. We are looking at time series data that has periods both in years and months, which allows us to see seasonality over a single year as well as across decades, giving us insight into what factors impact attendance, such as weather, accessibility, holidays, major events, etc. In our analysis, we determined that attendance at Redwood National Park was routinely highest in the months of June through September, peaking in July, with low average attendance between November and March. This is in line with the desirable weather patterns for traveling through the area at this time of year. Deseasonalizing data allows us to generate forecast results independent from seasonality in order to determine what trends a data set follows and if the data deviates from that trend. Record monthly attendance for Redwood National Park was recorded in 1988, but year-over-year data showed that 2 years following, in 1990, there was a massive decrease in visitation. Similarly, in 2019, we were up and following a similar trend, only to be cut short by the pandemic.
Deseasonalized data can also help us identify and predict trends. A common way of analyzing trends using a graph is to add a trend line. This allows us to see that our data set has a gradual but downward slope, meaning that visitor attendance has been decreasing regularly since 1979. In 1990, there was a massive drop in park attendance. After doing a little research into the background of the period, we found a few prominent events that could have impacted this data. In 1990, the environmental movement Earth First organized and participated in many protests, but became associated with violence when its leaders were involved in a pipe bomb explosion in Oakland in 1990. Following this, people weren't interested in being caught in the crossfire. In fact, visitor rates only began to rise again in 1994 when there was legislation passed directly impacting logging in old-growth forests. In 2016, there was another peak to this data, which coincides with the legislation of marijuana in California. Being that this region is known for that, it only makes sense that tourism benefited from this change in policy. In 2019, data was trending upward yet again, still not reaching all-time highs, similar to the late 1980s. This is consistent with the overall downward trend of this data set.
In order to determine which prediction method best suits our data, we created projections using 3 different models: the moving average, exponential smoothing, and linear regression forecasts. Based on the graphs shown, we determined that projections for the moving average 3 were closer to actual attendance records for Redwood National Park than that of the moving average 5. You can see this displayed in the fact that the red line is consistently closer to the blue line than that of the green. And also in the mean absolute error between the two of them, where for the moving average 3, it was 13.8%, and for the moving average 5, it was 14.3. Next, we use the moving average 3 forecast to make comparisons to our exponential smoothing and linear regression forecasts in order to choose one method that best suits our data. While projections for the MA3 yielded a 13.8% mean absolute error, we calculated that using an alpha of 0.75. We can generate projections yielding a 3.1% mean absolute error using the exponential smoothing method. It is because of this that 2023 projections in this model are more accurate than that of the moving average. The linear regression model, however, allows us to calculate projections using a formula that accounts for one or more variables impacting the data. In this data set, we used dummy variables to calculate the coefficients of all 12 months of the year. Then we took these coefficients and applied them to the standard linear regression equation where y equals the intercept plus alpha times x. The linear regression model is an excellent display of seasonality within the data set as it shows recurring highs and lows each year within corresponding months, May through September. While this window of data is relatively horizontal, it actually shows an upward slope, which is not in line with the decreasing projections from other models. In addition, the mean absolute error value was 22.86 generated through linear regression, which was much higher than that of the other two methods that we used to analyze this data, indicating that it is not the best model to predict this specific variable.
So in conclusion, based on these three projection models that we used, we determined that the exponential smoothing model offered the most accurate forecast for attendance rates at Redwood National Park. Because this model had the lowest mean absolute error and offered higher projections for 2023, which are more on trend than that of the linear regression model shown below. Thank you for listening, and go visit Redwood National Park and skew the average.